Another way to define a 3D shape is the extrusion method. An extrusion creates a 3D shape by pulling a 2D shape, giving it a third dimension. The process begins by defining the 2D shape, often using a polyline, which is an array of 3D coordinates representing a 2D surface. Using 3D coordinates to define these 2D polylines allows us to place them anywhere in 3D space. This 2D shape is then made 3D by giving it a direction vector, which is perpendicular to the surface, and a distance to extrude the surface. The 2D surface is then extruded in the direction of the direction vector for the distance given. Extrusion is a very common method for creating complex shapes with uniform thickness, such as pipes or structural beams. The extrusion method is often complemented by the revolution method. The revolution method is a technique used to create a three-dimensional object by rotating a two-dimensional profile around a line called the axis of rotation. This method is particularly effective for generating objects with rotational symmetry, such as spheres and cones. To use this method, you first define a 2D cross-section of the object, which is often a polyline. This profile is then revolved around a specified axis of rotation, creating a solid. One can control the angle of rotation to create a full revolution, which would be 360 degrees, or a partial one. The next method of 3D modeling is a point cloud. Point clouds are a unique method often used to create 3D representations of existing physical equipment. A scanner uses technologies like LiDAR or photogrammetry to measure a large number of points on a real-world object. The output is a massive collection of points in 3D space, with each point defined by its X, Y, and Z coordinates. While some software can display a point cloud alongside geometric primitive shapes, editing or modifying it is extremely difficult, if not impossible, in its raw form. Therefore, the two data representations would simply coexist in a single file. The final method we will discuss is tessellation. Tessellation is a different approach that represents a complex surface as a collection of smaller, uniform elements. The most common primitive surface used for this is a triangle. When an element is a 2D surface, like a triangle, it is often called a facet. The tessellation method can be used in conjunction with the point cloud method to represent 3D objects. Once a point cloud is acquired via a scanning process, this point cloud can be turned into a 3D object using the process of surface reconstruction, or skinning. Through this process, the gaps between the points are filled in to create a watertight, usable 3D surface. Tessellation allows this reconstruction to occur by connecting the points with facets, such as connecting 3 points to form a triangle. Another common method of tessellation uses cubes as the elements rather than triangles. This application is often seen in computational fluid dynamics, or CFD.